See your face. Hey, everyone. We're live. Thanks for joining us. We're excited. The Akash Mainnet launched, and I'm Gavin from Figment. I focus on protocol. Matt.
Hello, I'm Matt, CTO at Figment, and I just was excited to participate in the upgrade that Akash pulled off without a hitch just a couple days ago.
Hi, I'm Greg Osuri. I'm the CEO and founder for Akash Network, and I just launched a fresh blockchain and successfully completed a fork.
Hey everybody, I'm Bas Manzalji. I'm the CEO of Akash Network, and really excited to be here.
So yeah, just a little bit of preparation here. We're experiencing maybe a few connectivity issues. So, there might be times where cameras kind of go out or whatever, but we're going to do our best to kind of make our way through here. We'll take questions in the sidebar at times, like when it's, when there's a natural pause or whatever, maybe we'll just check in to see what kind of questions have been asked. Probably chat for about an hour. Maybe it's good to start with just kind of a high overview of what Akash is. This is a pretty exciting, like real use cases right out of the box, right? That's not like distant future, right? Like what's Akash and who's going to use it?
Sure, I can take that. I did lose the question a little bit, but I'm just going to repeat the question. My connectivity issues. The question is, what is Akash and who's likely to use it?
Yeah.
Well, Akash, in a very simple terms, it's the world's first open source cloud, right? So it's non-custodial, it's self-sovereign, and it's permissionless, like any other open source software. So the appealing part, really, I think, is the user experience for Akash. Imagine a cloud where you don't need to give your information or your name or email or need to get approved by somebody to use it. Makes it extremely programmable and extremely rapid. With this very rapid style of provisioning and unprovisioning, you get this programmability that you'd never experienced before. Think of it like Uniswap for deployment. And an open marketplace, of course, the advantage is participation. With wider participation, means significantly better supply than what you normally can get in a closed marketplace, means lower cost. And so it's really appealing to anyone that is paying exuberance of money to the cloud today and not very happy with the closed nature of the cloud. And if you think about cloud being the fabric of society, I mean, compute is what runs the society today. And considering that fabric is increasingly getting closed and increasingly getting oligopolized, the mission of Akash is to break that cycle and give the layer back to the people. So it's a people's cloud.
So there are things that are important to the individual user, and then there are things that are important to the all of the users, right? It's open as a protocol, so normally if I go to provision something from AWS or whatever, it's just kind of a black box. I ask for what I want, they give it to me. So like why is that important as an individual? What is it what's the value?
So, as an individual, what do I get? Like as a developer?
Yeah, like it's lower cost, right? But like how much lower, and why? How is it lower?
Right. Sorry, I'm going to keep asking you to repeat the question because It is breaking
That's
up for me, my connection problems. So what it means for a developer or a user, lower cost, we're looking at anywhere. Right now, it's about 40% or 50% cheaper than what you would pay in the market. And slowly that is about to get about 2 to 3x cheaper. And in the future, with some of the economics hacks that we have, it can even go up to 10x cheaper. And I'll get into that later. And second thing is the usability, right? So today, if you want to deploy something, it's extremely complicated. There's so many layers that you got to peel just to put a simple website around on something like Amazon, right? And Akash is really designed for a developer with a modern outlook in mind, and the SDL file interface that we sort of like design makes it much simpler without compromising the capabilities. It makes it extremely simple for you to deploy and takes the inspiration from Docker Compose and really extends that to the cloud, right? So it's just a highly productive and open environment for developers that's lower cost as well.
So it's easy, fast to deploy, lower cost. It's going to get even cheaper. How does it get cheaper? Like, why is it more expensive now than it will be in the future?
So the reason why it's expensive now is because the price set by the provider, whereas on Akash, the price is set by the user, right? So it's a reverse auction mechanism. And when the user applies a price, you essentially have a fulfillment that comes from anybody that is willing to take the order, right? So right now, if you think about the closed systems like Amazon, Google, Microsoft, they have their own set of data centers. I believe they have 200 data centers or something. Amazon does, right? Well, there are about 8.4 million data centers in the world today. So in the future, when all these data centers eventually will come to Akash, you're going to increase it. You're going to have naturally a higher supply, which will naturally cause lower prices, right? Just so much unused capacity out there that's not being listed, right? And the reason why you have this unused capacity is most companies or organizations that operate a data center normally have to plan for peak. For example, you have Intuit, right? Intuit is a company behind TurboTax. And during tax season, they run their data centers at near 98% capacity, whereas off tax season probably at around 3% capacity. And so normal off season, they're not, and they have all this capacity they don't normally use. In a scenario like that, they don't really have a way to dispose of that capacity. So for them, they're going to take anything they get for this capacity, right? So in a reverse auction mechanism where the user sets the price, and when you have the supply competing for the price, the lowest bidder normally gets the job. So that fair market based pricing will cost as in
sorry, can you
higher,
repeat
higher
the very last sentence that you said?
The competition that the reverse auction marketplace sets, where providers bid for a price, will naturally lower the cost, considering there's going to be considering there'll be an increase in supply.
So there's a two-sided market. There are people who are providing these underutilized resources, and then there are those who are using the resources, and
right.
The ones who are setting the ones who are it's the users say, I'm willing to pay this much for this, and then if that's high enough, then there will be a supplier who they're matched with.
High enough, or the supplier just feels like they can take whatever they get and they don't have enough jobs for them to offer to, right? Because there is no computer marketplace in the world. There is no spot market for the world. And this is the first spot market for the world, right? So it's like whether I dispose of it or if I don't, right? Yeah. Because the capital is already spent on acquiring this compute, these servers.
So does that sort of imply that containers will get moved around between providers? If a company like Intuit, as that example, as they come into their busy season and they start to use their own resources, that's going to make the system very dynamic? How does that work?
Correct. So that's one of the properties of Akash. It's an ephemeral system. It's not. There's no permanence in the system. So the workloads have to be designed to be moved around, and that makes it challenging for some workloads, great for few types of workloads, right? If you're doing something like data heavy, you need the basis that Akash is probably not the best system, but where you have, if you can have a more scalable architecture, a more ephemeral architecture, and more redundant style architecture, Akash is excellent for that, right? So really what Akash makes a developer to do is really rethink how they're building these applications. We take a lot of things for granted in the cloud today, so or in data center setup today, which I believe it will be moving off from like this permanent mindset to more impermanent mindset as the workloads get more distributed. So Akash really demands that distributed design, or else you're going to not have a lot of success.
Right. That's interesting. So does that imply that sort of larger scale applications might move parts of their deployment onto a cache and keep parts, like central databases and things like that in a more traditional cloud environment?
Yeah, that's the understanding right now. I mean, we are working on a more permanent pricing and more long-term like storage solutions, but right now it's really ephemeral. The architectures that we like to see is more edge optimized and more compute heavy and less data heavy, right? So edge optimized in the sense you're really, because right now Equinix is the largest provider for Akash, and Equinix has about 200 data centers that are interconnected. It's the largest interconnected data center network in the world, right? And if you want to get access to Equinix data centers today, you go through hoops and like go through a vendor managed, vendor style offering, right? Whereas you come to Akash, you can get access to this incredible infrastructure with a Docker Compose style user experience, which all of us love to use, right? So giving you that user experience that is simple and just really beautiful, right? While giving you this access to the incredible network of computers is what Akash is offering, right? And we have other amazing providers like 6x7 or Orion networks, and these are not normally these are providers you don't normally hear about, and they can give you like 5 millisecond latency in California, or 5 network latency, right? So if you're doing anything communications or any gaming style applications or anything that can leverage this like low latency networks, Akash will be the place to go. And some of the providers are even looking at giving you access to cell phone tower, edge data centers where they literally are like hosted right on the tower or right next to the tower. So that style of like very like niche data center access is what you can get with an open marketplace. So as we onboard our providers, we're looking at like highly niche providers that you don't normally see Amazon's or big clouds, right? So rapid provisioning, deprovisioning, edge optimized workloads are the best case scenario right now for Akash.
Got it. That's pretty cool. It's probably actually a good segue to a question that's been sitting in the sidebar about how would you compare the usability for someone versus, say, DigitalOcean or Vultr? So someone's comparing, I'm thinking, they're probably thinking about a pretty simple web app, just given that sort of a comparison.
Right. So DigitalOcean or Vultr, you essentially have to boot up a VPS and manage the entire VPS for you. You got to manage the servers. Gosh, you don't access the server. In a sense, I don't want to use this term serverless, but essentially the abstraction that you get, because serverless can be construed as just functional programming or function as a service. But this is really similar to Amazon ECS, Elastic Container Service. Like, have a container, run the container, configure the container, but just way better user experience than ECS, right? Like the YAML file abstraction is just a lot simpler than the CloudFormation templates that you have to go and figure out that crazy JSON text, right? So this is like a very simple an easy version of ECS. You don't have that kind of capability on DigitalOcean or Vultr.
Right. So for the developer, the step really is to just create a container. And as long as they can create a container, then running it.
Create a container, usually. Yeah, and we have this repo called Awesome Akash on our GitHub, and there are about 90, close to 100 applications. This is a community-managed repository with all different kinds of applications, all the way from lots of front ends, multi-tier, block explorers, and all kinds of things that you can do on Akash. Even running nodes itself on Akash, like running Akash on Akash itself, the Akash node. We have all kinds of examples. It gets a little meta there, right? That you can look at and just really, what I'm proud of is we had this beautiful community curated repo that came into existence during a testnet phases, and we were surprised as to how easy people found it to actually write these STL files and share with other people, right? So highly recommend people to go check it out, and you'll get an idea as to how simple it is to use the system. It's still command line, but it's actually really simple on the command line itself, and we're building a web UI that makes it much simpler. You'll probably see a Uniswap style, click, 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 no login, none of that nonsense, right? And just deploy. And we think that's how an open source cloud should look like, without collecting any information that could be potentially compromised.
Right. Yeah, I was actually wondering. I was thinking that sort of a layer 2 on top of a cache would be something like Heroku on top of Amazon. Like a layer that makes it even easier for devs.
Yeah, we're looking at how to design one of those layers, right? My ideal preference, I actually we have this code written, I wrote 5 years ago, on how to do this Git style deployment, right? Just Git push and let Git manage the whole release for you, release lifecycle, because Git is beautiful data structure. The Merkle data structure is really cool for integrity-based bundles. So in an ideal scenario, you should be able to Git push and deploy for the most part, right? And that makes it a little challenging how to build a Git layer on top of a decentralized network, but ideally that's where we want to go.
So this might be a little bit too deep in a rabbit hole, but a couple of the engineers that I've talked to at Figment, the first question they had was, how does DNS get handled? Because they're like, well, do I have an IP address? How does that work? That was their first question.
Yeah, you get an IP address. Unfortunately, DNS needs to be an external actor watching your IP address change and setting the DNS as a bot, right? We don't. You can set a host name in the host header while you deploy the application, but then you have to map that host to the IP address you get back. Some providers choose to give. Some providers actually have. We recommend providers to do a wildcard route, and you get a randomly assigned domain name to the wildcard route. So you do get some randomly assigned domain name for you, but that's not permanent. So depending, so you gotta really when there is a restart or a reprovisioning of your application, the IP address will change if there's a provider change, right? And then you're responsible to make sure that IP address reflects in your DNS records and the expected. And we have a beautiful pub subsystem that we wrote that currently is active on Akash, and the event system is really powerful. So stream and catch deploy events that are relevant to you, and making the appropriate changes based on this event stream is what we recommend people do.
Right. Okay.
And we're actually working on a more scalable worker model where depending on that's based on this event stream that you can deploy, and a smart contract style function. You just the function and you set your invocation parameters based on these events, and it should get executed on your behalf. So that'll make it a lot easier to like have bots on chain itself, and it's lots of work to do. So we imagine that's how we do auto scaling and all kinds of other things,
Mm-hmm. Well, I sort of hijacked the conversation there. Gavin, do you want to get back in with some more questions?
No, it's great, especially the people who use these sorts of things day in, day out. It's really good to get some of the kind of more granular details identified, because it's kind of magical what it is you're doing, sort of. So it's like, well, how do we, like, okay, how does it really work? So like, what about
lots of opportunity? I really like that event thing that we have, the PubSub thing, the broker thing. I mean, I wish people could write a lot more tools. Like, I want to see like an auto scaler. I want to see a DNS like DNS not resolver, DNS setter, or provisioner. There are lots of cool things you can write with the PubSub system.
Yeah, so it's this initial kind of like you've got the bulk of what it is, what you're going for to be as decentralized cloud as possible, but there are all these other components that still need to kind of bridge us and that need to be built, right? So
we didn't want to wait till we build everything. We wanted to build a base system, and and purposely, but we didn't want to overbuild it, because now if we build it, it's all right, and we can build it in the dark, versus building it with people is just what we learned is way better, being an open system. So and we'll probably do like a hackathon or something to give people ideas on what to do and how to extend the system, essentially.
Absolutely.
Yeah.
I think that makes a lot of sense, like just to have a lot of people tinkering, the people who want to use it, the people who want to explore it, building it together is an exciting way to do things, and getting more eyes on it and tinkering. So like, when I think of, you could build this as a monolith in the dark and then launch it one day in years from now, but you can launch it now with you kind of have a few things that you have to tolerate and then improve upon. But like now, as an example, like Dfinity I see as one potential competitor who has done that. They kind of just kept everything in the dark, and they just kept building this monolith. So are there, like, what's the landscape look like? Are there other, like, is Dfinity an example of someone who's kind of trying to do something similar, or maybe talk about others in the landscape? Who else is trying to attack this problem, and how might Akash be different?
Boz, you want to take that?
Sure. All right, here we go. Can you guys hear me?
Yeah.
Yeah. So there's a few players in the space, especially in the decentralized space. Dfinity always gets brought up, as well as Anchor, Golem, a few other, iExec, for example. They all have different models in terms of how they approach the market specifically. So, for example, Dfinity is trying to build this huge internet supercomputer, and they're trying to match the excess supply of compute resources in the market to really to rebuild the entire cloud architecture from scratch. And fundamentally, when you look at cloud, right, this ignores basically the last 20 years of development in the cloud infrastructure space to begin with, and really forces users to adopt and take on huge costs of transitioning application architectures. So, when you approach a developer and you say, okay, we have this thing, but to use it, you have to rebuild and re-architect everything from scratch. That provides quite a few friction points to deploy. So why would a developer do that and drop all the tools that they've built and learn and they're comfortable with to deploy on something that's use case is fairly small? Secondly, when you look at the market relative to our market, the supercomputer use cases are relatively small relative to the market at large. So the market for application requiring supercomputers, such as short-term batch like CGI rendering, financial modeling, weather forecasting, DNA sequencing, all that's great, but I think the last time I checked, that market was fairly small. So I think around $400 million relative to everything else that we're tackling, which is about 200 billion. So it's really about market size, the market you're tackling, but also how you're positioning to win developers to launch and requiring them to re-architect and rebuild just to launch on a specific internet supercomputer for a specific use case is it's going to be very, very challenging. But you know, a lot of different people are approaching the same exact problems because they identified the same exact opportunities. It's just a matter of who wins in this case and what kind of applications get adopted in a frictionless environment.
I think overall, like what's true is why.
Hey, Greg.
Right? What we do with excess supply.
I couldn't hear you from the beginning. You want to start again?
Sorry, I'm going to repeat myself. I mean, what is true and what's agreed across the board is there's a ton of excess supply, right? Dfinity, Golem, all the projects, the promise is, well, you have incredible unused capacity, use installer agent, and based on the use cases that we serve, we can actually use the excess supply. Whereas Dfinity is unique and they're a smart contracts platform, right? We don't really know, and I believe the competitive sphere is really, Ethereum's and Solana's and that world. And we're not a smart contracts platform, right? We're a cloud, service provider network, right? And the closest that would come maybe is iExec. But iExec is limited to running batch jobs only. So, short running batch jobs, whereas Akash is optimized for latency sensitive as well as batch jobs, right? You can get you can run a web app on iExec. And I believe there's Golem, but Golem is really not a decentralized platform. It's you have usernames and you pay using credit cards, right? So Akash is the first and only fully open, as well as non-custodial in nature. That is pure full cloud.
That makes a lot of sense. So when I think about when I use a cloud provider, there's some sort of assurances of quality and support if something kind of goes sideways or whatever. So what do you do here? How do people know that when they use this, they're going to get, like, I know you mentioned like high quality infrastructure providers, but how do we assure that all
right.
the providers do provide, like they don't provide a second tier service, or I don't know.
So we don't have verifiable compute. We don't have verifiability for compute. So what we do have is a reputation, right? So Akash has a feature called Audited Attributes, and as cloud providers list their compute, they also, provide identifiable information, which is their names and who they are and what tiers they have. There's certain attributes that they advertise, like the location and whatnot. And a lot of these attributes cannot be verified on chain, right? But they can be verified off chain. So we have this like auditor model where a trusted third party essentially audits these attributes and publishes those results on chain. And as a tenant, you can choose to trust that the results. And if you trust the result, you by proxy trust the provider. So essentially, it's a reputation model, and you have the auditor's reputation at stake. And if Equinix says who they are, the auditor is essentially like giving them thumbs up. To seed the audits, Overclock Labs, the company behind Akash Network and the core contributor to Akash Network, is acting as the current auditor, and we expect to see a lot more auditors come on board, and we're going to build out the infrastructure a little better with more incentives and disincentive model and scale out. So now essentially, trust the Overclock Labs. The key for them, and if Overclock Labs tells yes, this is Equinix, you essentially trust Equinix, and you can expect the Equinix level. And each, of course, provider has their own way on how they handle issues. So they usually publish what email address, if there is one, to email them, and you can essentially have the same level of like issue resolution that you normally experience today with the cloud.
So yeah, okay, and even we can probably relate as a staking service provider if there's an issue with something, people contact us, even though it's like a decentralized chain, we have a point of contact if there's an issue.
Right. So that's a big difference, right? Akash is not verifiable platform. And a lot of these other smart contracts are verified compute. And verification it's the trade-offs that you have, right? So if you want verified compute, well, the trade-off is this: you got to rebuild the entire architecture in verifiable mode. It's not exactly applicable for all the applications. There's certain applications that can use it. Akash is generic, right? It's not verifiable compute, and we do improve the service guarantees by providing this more of a trust layer on top of the decentralized network through audited attributes.
Yeah, I recall Golem running into the same they're running into this wall, needing to verify compute being a huge obstacle to overcome. So what about when can people use this in production? I mean, I assume right now are people using it in production right now, or is there kind of a ramp up to be all right, it's safe to rely on this?
There are about 7 users. We launched it yesterday, so there are about 7 users on production right now, according to the stats active, and I think they're a few applications. Let's see.
But I mean, would you there's
there are about 3 applications deployed.
Right?
Yeah, so I'm deploying. It's early, right? So we're deploying a lot of our workloads first. There are a lot of people that use are close with us that are deploying our software. So it is an early system. Like any early system, I'm not going to promise this is going to be fully scalable. The 3 areas of focus for us: scalability, stability, and security of the system. So yes, recommend is to deploy less mission critical applications and really learn how to deploy in Akash, because you have to think about redundancy. You have to think about the distributedness of your application, and you got to think about the ephemeral nature of the storage, right? So with assuming that if you walk in with the same assumptions that you're used to on the regular cloud, it's not going to be kosher, right? You're going to run into a lot of trouble. So we suggest putting sentries are a phenomenal place, right? Because or instead of full nodes, sentries are quick and easy to boot up. And less mission critical applications, I think, is a good start right now. And as we scale up and as we get more comfort, and it's also infrastructure platforms are climbing credibility ladder. And as there are going to be more tools for managing your databases, your backups, your restoration, all these things that we got to build, you get more credible and more comfort in using Akash, right? So right now, I'm deploying on Akash and stuff, right? Without that, I would not be comfortable.
So right now, you're using Akash, I think.
Yeah, so I have a MySQL-based application that I'm deploying on Akash, but I have to go write all the database backup and restoration scripts and the bootstrapping scripts and the monitoring infrastructure and all this good stuff, right? So without all that, I'm not going to put an application in production. So,
how is the continued development funded? I assume there's a foundation, and then there's probably, I think there's a community pool as well.
Yes. Well, so Akash Overclock Labs is a very well-funded organization. We have runway that lasts us about 15 years, thankfully, and the core team is full-time on developing Akash, and there is a community pool as well. I mean, now we have about 400K AKT, which is about not bad, just $3 million, I think, in the community pool that we plan on deploying for development. And we're going to have a more formal bounty system and what we're going to incentivize in terms of development. And Currently about, let's say, 6 engineers are full-time working on it, and we plan to double that in about 3 to 6 months. So that's how it's being funded.
I think the last thing I caught was that you're planning to double that in the next
3 to 6 months.
Right.
Yeah, one thing I want to add is our foundation, the Decentralized Cloud Foundation, is the one who's going to be the entity that's actually managing the grant system. So we've already started breaking ground on just thinking through some of the things that we want to enable and provide basically RFPs to the community to continue adding and extending the capabilities of this platform. So look for more announcements probably sometime in late Q2 once we have a little bit more resources internally, more bodies to begin managing that type of foundation. One of the things that I've been inspired by is basically the ICF and how they manage community, manage the grant ecosystem. So really taking a lot of cues from Billy and the great team over there to understand what works, what doesn't, and then accelerate these grants as soon as possible. So there's a lot of work ahead of us over here.
If you want to use these services, cloud services, do you need to use AKT tokens?
Yes. Right now, you have to use AKT tokens to use the cloud services. Although we are working on a multi-token settlement mechanism, but that requires IBC to fully get to some level of maturity before we can enable that, right? And lots of exciting things we're going to start proposing very soon on like the multi-currency settlement too.
Yeah, and just to add on to that, we recognized, Greg had the incredible foresight to really think through about enabling multi-token settlement, right? Especially in positioning ourselves within the Cosmos ecosystem to unlock IBC, was a strategic bet that will pay dividends as soon as the entire ecosystem matures a little bit more, and then transferability within the ecosystem continues to mature. So you can imagine a world in the future where Kava can be enabled, or Kava's USDX can be enabled to pay for compute as well as other digital assets. And that will need to be thought through, but we'll be very closely aligned with the community to unlock these different flexibilities and capabilities to reduce the barrier adoption, as opposed to forcing all users to use X.
Yeah, and one thing is like the current mainnet 2 is version 1, right? So, and the reason we kept it super light and we essentially covered, delivered what we promised in the white paper. But from now moving forward, we want community to be a lot more involved than what they were till version 1, right? So moving forward, we're going to be extremely forthcoming in how we do development with a very strong proposal framework where we write the proposal, and if there is a community member that want to pick this up and go with it, we'll fund that, or we will essentially only do things that community is not picking up to do, right? So we want to put community first, both in terms of proposing features as well as developing features as well. Yeah.
I've got a question here that Clay from our team wrote. He said that we want to know, we've got the electricity crisis in Texas with supply demand issues. How could Akash deal with a supply demand issue, in this marketplace?
I'm sorry, what's the supply demand issue?
I can only assume what he means here is that if suddenly prices just like spike and you're already dependent on using Akash, or all of a sudden there's a scarcity, maybe not enough compute or something. How do you expect the marketplace to adapt?
Well, it's a free market, right? So it's a demand supply that sets the price, and there, with more demand, the price is going to increase. With more supply, the price comes down, right? And we don't have any say or intervene in the demand supply forces generally. So,
and ostensibly there'd be more flexibility. I assume, like there's only so many power providers, right? Electricity providers. Whereas, if all of a sudden the price starts going up, it makes more sense for unprovisioned resources or underutilized resources to be plugged in to kind of capitalize on that, right? This is
right.
The idea.
Yeah. It's permissionless. Anyone, you can go on, if the prices are super high, anyone can go on Amazon and put up one of those boxes and leverage what you have on Amazon and sell that on Akash. In fact, we see a lot of the use cases where people have paid for reserved instances. People have actually approached us with these use cases. So enterprises normally, pay up front for getting heavy discounts on Akash on the cloud, up to 70%. And these are time bound. So if you don't use them in 3 years, you lose them. It's a perfect place to offload some of that capacity on Akash too, right? So it's actually making the current cloud more efficient in that sense.
So how does a small provider or somebody who someone who's not in the Equinix scale, or even somebody who's thinking like, I should go and lease a box at AWS and eat the discount and then provision that out into Akash? How does somebody go about thinking about it and then actually doing it?
You can essentially, so you can go boot up a box, install Akash agent on it. Have Kubernetes, working and install the Akash agent in the Kubernetes. The question is like, are you trustworthy or not? So that's something that they should approach us, and we'll do the valuation. And we are formalizing some of the things in terms of like, how do you control like the standard stuff that you normally see in highly regulated environments on like who has access to the box and can we KYC that person, and like it's a lot of these like security requirements that they need to check off for us to like basically attribute that these guys are legit. But they can list, and we don't have to go through us, and you can have another auditor with their own security standards and own audit standards, or you don't need an auditor to actually list the thing, as long as you have someone like willing to use your compute. They can go ahead and use it as well, right? So for someone that is small and just wants to list their compute, and as long as they have a buyer for it who's willing to use them, it's fully permissionless, you can go list it. But if you want more trustability and you gotta really produce and show, and it's like the Uniswaps. It's like listing on Uniswap, right? Like, how do you know what token is legit or not? And you have this like Uniswap lists, right? Like, unless you have to go to CoinGecko, or unless you're listed on CoinGecko, and CoinGecko is going to has some verifiability that these guys are legit and these guys are who they say they are. So our version is a little more extended version of that listing mechanism.
So it's interesting in a permissionless market like that with layers of verification. It seems sort of likely to me that there could become sort of several tiers of service that sort of start to form, where you might have unaudited but very cheap services, and then sort of like a ramp up from there.
Exactly. So like if you're doing machine learning, you don't need that level of security. You can actually, because the inputs and outputs are very contained, right? It's a very functional style. But if you're putting a sensitive database, then you probably want the level of security. And that's where we want to see a more evolved market, the tiered like model, right? Yeah, you want like tier 4, defense grade security. Then every person that has access to the servers is going to be KYC, background checked, like every log of an server access is going to be like checked and all that. Like you have this different levels. But if you're just deploying a machine learning workload, you don't need that kind of level. So, it's all all you care about is finding the cheapest compute that anybody can offer, and you don't have to go through this like hoops and stuff. And that's really exciting part of like a free market that we like to see developed on Akash. Yeah.
Because for some use cases, you might not even care about reliability. If a process fails, you'll just run it again, and it may not matter.
Yeah, when there's like input and output, that's just numbers, a part of a bigger job. Yeah, definitely. Like someone could build a scheduler that would like span across the entire network, and do all kinds of amazing things. That's what when I said it's really programmable. That's where I meant. Like you can actually write stuff on top of Akash that are really exciting stuff like hyper distributor schedulers and whatnot.
This is maybe a slight jump. Have you guys distributed those mini supercomputers? The little mini desktop computers?
We have not. So we postponed the super minis to post network launch. So initially because if you don't have demand, there's no point in like shipping the device. Building the device is the easy part. We have a prototype and all that stuff. But for someone to buy this device and for it to make sense economically, you need the workloads, right? Without the workloads, you're not able to. So the device is essentially a GPU optimized device for running machine learning workloads. And as we develop so now we launched the network the next few months, we're focusing or looking at really enabling the GPU side of things, and multi-tenancy in GPU is not exactly straightforward. So once we figure out the multi-tenancy model in GPU provisioning, anyone with a super mini essentially is positioned to serve a larger machine learning workload, and that's the economics behind it. And it makes sense for us to ship these boxes. And we made and the first batch is about 300 boxes, right? So we have a prototype at home, and we announced that this is what the box is, and we started doing pre-sales, and we sold out all 300 of them, and we have roughly about 15,000 people on the wait list.
Oh wow!
Seem to love this box, and it looks pretty cool. But it's not exactly the most powerful one. It's a home.
Sure.
It's really meant for like plug and earn. It doesn't do much of anything, and it was inspired by the Helium box essentially.
Well, that's cool. I think I'm on that waiting list.
There's a comment to the chat.
Do you know anyone I could talk to?
I can't get out.
Asking, hey, can you speed things up for Ukraine, Russia, Belarus?
So
you don't need super mini to provide compute. You can be on Amazon.
No,
and
absolutely.
Provide compute in Akash, and you can still start earning rewards.
We actually have a fair number of servers in our own rack, actually, because at Figment we do a bunch of stuff on bare metal, and it's pretty heavily utilized. But we do have a few spare machines that are sort of sitting around. But there's probably more. We probably have more spare computer cycles than we have mental cycles at the moment.
There you go. Yeah, it's always the case, right?
Yeah, and the compute cycles there are probably outweighed. There's not a lot there. It's a pretty small. We would be a pipsqueak in that little market, I think, at this point.
But we have like all kinds of
cool
deployments, and one of the most exciting deployments that or use cases that I come across and I'm really excited to enable this is machine learning, right? So a lot of folks that have AI companies, especially from the growth stage onwards, operating an AI company on the cloud is very prohibitive. You give 20% of your revenues to Amazon, essentially. It's, Andreessen Horowitz had this beautiful article, and they highlighted all the AI companies that they found how difficult it is to actually run an AI company today on the cloud. And so a lot of these AI companies, they tend to bring the compute in-house, the GPU compute in-house, and like any in-house compute, you only probably use that maybe 2 hours or 3 hours a day while you're training, and most of the time you're not using it. But when you really want to use it, you tend to need more than what you have, so you go to the cloud. Even sometimes even if you have the compute in-house, right? So that's really where Akash shines, is when you can actually install Akash and earn credits, Akash tokens, when you're not using them. And when you do want to use the peak, when you peak your own capacity, you can go to the Akash network and really create like a P2P GPU cloud, and it's perfect for Akash use case, a pure P2P machine learning GPU cloud.
And and just to add on to that, when you look even at the data intensive market, just like machine learning and AI, it is an ideal use case just given their gross margins. Their gross margins are on the same level as service companies. So you're looking at a 50% gross margin, growth stage company relative to their SaaS counterparts, which operates around 70 to 90% margins. So for these companies to scale, they need to obviously improve their bottom line. And to improve their bottom line, they have to increase their margins, but also lower their costs. And most of those costs right now are being spent in the cloud. So when you have this hyper scaled peer-to-peer GPU marketplace that operates quite efficiently, but also solves the specific, very acute pain point for a very fast growing industry, you can, it doesn't take a crystal ball to see how we can help these builders and these entrepreneurs scale their businesses faster and make them more attractive investment opportunities to the VC world, which is what the article from Andreessen Horowitz was highlighting.
Mm-hmm. That's really cool. And actually, I hadn't thought about it before, but what you just described about using, that someone might be both a vendor and a consumer essentially, and sell their excess capacity and then use their credits for peak is it's kind of like battery for compute. That's really cool. That's really compelling. And I hadn't thought about it that way before.
And so less trust, that machine learning requires a lot less trust than a sensitive database. So really want to go aggressively after. The only thing we need is to enable the GPU multi-tenancy on GPUs right now, which is the problem we're working on.
Mm-hmm. So someone just popped up with a question about I guess dynamic price dynamics, and as the market price changes, I guess when you deploy an app, you're committing to a lease, if I understand correctly. So that's sort of like a time-bound lease at a given price.
It's spot, so there's no time bound.
Okay, there's no time boundary. So as a you need to be, I guess your credits are being you're committing credit in Akash tokens that will be drawn down over time.
Right.
Like how do you manage your costs? How do you sort of account for that over time?
Right. So scenario one, Akash is a volatile token. So right now Akash value is being going up. So it makes less sense to use Akash tokens, right? So right now, unfortunately, you got to use Akash, but we are working on a repricing mechanism, right? So today you agree that you're going to offer compute at X cost. Essentially, we're working on a way you can actually renegotiate your price to any event. So that could solve the volatility problem. And a second is like, well, yeah, anybody can, the provider chooses to kick you out, they very well can kick you out, right? So we're working, that's where the auditors come into play. And we're working on a mechanism to have the reputation based on like when they're not like respecting the lease and kicking you out, and potentially have some sort of a repercussions there. So, and now, but understanding that this is a spot marketplace, right now there's nothing preventing somebody to kick you out. Right now it's a very, very bare bones. And these are some of the problems we're working on. But the second, I think a lot of the long-term leasing aspects will be solved when we have the long-term leasing contracts enabled, right? So right now it's all pure spot. It's exactly like using spot market on Amazon. So, yeah. Okay. And there are no like permanent. It's all ephemeral. There's no permanency. you got to design the applications to handle that.
They need to be ephemeral.
Yeah.
That makes a lot of sense.
And the reason why we didn't over-design this protocol is to really deploy it and understand their usage patterns, right? Like, our provider is going to kick you out when they need. Some do, some may not, right? Like, what kind of providers are there, right? Like, so there's a lot of these unanswered questions. So instead of us sitting in, like, we came up with all kinds of like exotic solutions about reputation, all that stuff, but we put that all away and we decided to just go pure first. And walking with these trade-offs, yes, you're going to have these trade-offs, but we will only learn on how to design a better solution once we actually experience this trade-off in person, right? I mean, if the solution actually, like, much higher in the application layer itself, where the applications are so redundantly built, which they should be, I think, that they can actually transition smoothly to other servers. If not, is there a, like, can we give like a warning in 15 minutes or 20 minutes you're going to go down? And can we like do something of that early warning systems? Or like, we don't know a lot of these, like what the user behavior is going to come out to be. Yeah.
No, that makes sense. I mean, I think that anyone who's been involved in two-sided markets knows that they don't know how they're going to behave.
Yeah.
So, yeah, it would be very easy to spend a ton of time building a model and find out that it doesn't matter.
Yeah, that's the worst thing. Yeah.
Yeah.
Just being mindful of the time here. We've got to.
Yeah, I was just gonna say we're creeping up towards an hour. So, Gavin, did you want to wrap up?
Sure. Well, just wondering what we got for this. Actually came in as a question. What do we have? What's next on the roadmap now with Mainnet 2 being launched?
Yeah, good question. So we have three essential categories, right? Scalability, security, and simplicity to a degree. So we're doing a lot of like and stability, right? So the next 1 month, we're essentially kept ourselves to be free so we can address a lot of these issues, right? We didn't plan to do anything for the next month, and of course there are issues that are popping up with all kinds of issues that normally will pop up. Delivering software for this long, you can understand if you plan everything in post-launch, and you're never going to get that done. But after that, we have a few items. A big thing is getting that the storage that we talked about, more permanent storage that'll enable you to do nodes and whatnot, in a less ephemeral manner. And we have the GPUs, the GPU marketplace that we are really serious about. And we're really excited about the machine learning workloads in the peer-to-peer machine learning cloud scenarios. And then we have the economics. I don't think we talked about it too much, but we have a new model that will actually reduce the cost by 10x by using inflation to subsidize the cost. So, we have this beautiful thing called inflation. As long as inflation is actually contributing to subsidies, it makes a lot of sense, right? So, and of course, we can offer, using this model, we can get the cost down, sometimes even 15x, right? So that gives a very attractive incentive for people to move their workloads off from Amazon or their current cloud. And of course, these don't last, and they only last however long the inflation can subsidize it. But, considering the Akash network is fairly growing, and the market cap we have can make meaningful subsidies to the inflation model. So we have very exciting stuff. And also we have the take income that we proposed, that the value accrual mechanism for the Akash token, where you take a percentage of the profits from the hosting. And we're going to be building that out. So that's going to, and when we're going to do what we're going to publish over the next few weeks.
Great, thanks. I have way more questions that I want to ask, and this has been a really great discussion. So maybe we can do it again. Thanks for
love to. Yeah. This was fun.
Yeah, I think we got all the questions from the chat for the most part. So yeah, looking forward to our next one. Thanks for joining us, Greg, Paz, Matt.
Thanks, guys. This was good. We pulled it off.
Congrats.
All right.
Bye, everyone.
Bye.